Hi, Katie and everybody from 8th period that is gone. I don't know who you are, but here you go. This is section 4.5. We are back at it after Thanksgiving break. And this is analyzing graphs of polynomial functions. This isn't my favorite section to teach. We're going to be doing a lot of plugging numbers into equations to graph things. And you know, that type of stuff. So the first thing that they talk about here is like identifying zeros and things like that. We're going to talk about like maximums and minimums and increasing and decreasing functions and stuff like that. But one thing I will add to the top of this paper is that polynomial functions are all going to be like curvy functions, okay? So polynomial functions is the set of all like the types of functions that we've been dealing with. Like the first one is like a linear function where it's y equals x, right? Then we have quadratic functions, which is y equals x squared. And then we have cubic functions, which is y equals x to the third power. And then we have quartic functions, which is y equals x to the fourth, and that type of thing, right? Okay. And we know what the graphs, should we label what the graphs of each one of those look like? Maybe? Sure? I don't care. We'll do little graphy things just really quick. What's a linear function look like? A line. Quadratic? A smiley face or frowny face. Cubic? Sometimes he'll have like a I don't know, kind of like a parabola, but one facing down. What's a quartic function look like? Most of the time a W, something like that. It could be pointed down, whatever. Okay, those are the main four that you'll have to deal with. You could go quintic functions, you could go x to the 8th power functions, whatever. But those are all polynomials, or the set of polynomials. So they're curvy things. If they're not a straight line, they're curvy things. So we're analyzing graphs of those things and talking about what happens at those places, etc. Right? Okay. All right. Locating zeros of a function. They want us to plug these numbers into this equation and go from there. All right. Do you want to divide and conquer, folks? Should we have like each one of you do a certain one or something? There is 7 of them. Then there's 7 of you. Yay. Okay. Okay, let's just go in order. Do you want to plug -2 in? Daniel? -2 into that equation. Make sure you use parentheses when you plug it in. You have -1. Eli gets 0. That's no fair. Tate has 1. Ellie has 2. Connor has 3. Carter, you have 4. Plug those numbers into that function, and we'll get numbers in a table. Okay, get your number, and then as soon as we're all done, we'll put them up here. And everybody can fill them in. We'll just make this go a little faster. I'm going to check. I'll check -1. I don't know. I'm going to check a negative number. -1. Okay. -1. It's going to be +1, -4. -3 +1. -7. We'll see if Billy got the same. Billy, did you have -1? Okay. But did you have -1? Yeah. Daniel, what'd you get? -17 off the chart. -17? Just 17? Did you get -7? Okay. What'd you get? I bet you, Eli, it was 1. Tate, what'd you get?
1.
1? Okay. Ooh, that's weird. 2? Ellie?
I got -1.
You got -1? I bet you're right. 3?
I got 1.
What is going on here? What's up, Carter? 4?
13.
13. I think that's about right. Okay.
Yeah, I think number -2 should be -29.
-2 should be -29. Okay. Oh. Okay. -29. Okay. Sure. All right, -2 is at -29, which is like all the way down here. So we're just going to plot them down there. -1 is at -7. Now we're finally getting onto the chart here. 0 is at 1. 1 is at 1. Then 2 is at -1. I'm just plotting these points. And then 4 is at 13, which is all the way up here. Whew. We don't have very many like points to go through. Do you know what this is going to look like? What's his parent function, by the way? What's the parent of this guy?
X2.
This is x to the third power. Okay. So he's starting in the bottom and he's going up, right? Because it's positive x to the third power. So he's going to start down here and he's going to go up here and he's going to have like a little hump in the middle. Can you see where he lives, like what he looks like? Okay. He's going to do something like this and he's going to have a little hump here and he's going to come down and he's going to have a little hump and go back up again. Something like that, right? Make sense? Ish. Oh, wait a second. I didn't plot those right. Ah, come on, Mrs. Comature. At 1. Come on, Mrs. Comature. 0 is at 1, 1 is at 1, 3 is at 1. There we go. We got to shift him up a little ways. Okay, here we go. Something like that. There, that's better. Okay, good. Determine the consecutive integer x values between which each real 0 is located. How many zeros do we have? Okay, we have 0. We have 3 zeros. First 0, second 0, third 0. We're going to say between where? None of them cross nicely, right? We're going to say between something and something. So this first one that's right here, he is between what? Negative 1 and 0 is where he's going to cross. Now, does that mean it's at exactly negative half? No. The next one, between something and something. What? Between 1 and 2. And then the last one is between 2 and 3. Yep, those are my zeros. And you can see that on the chart here. So my first 0 where it switches from negative to positive is between 0 and 1, right? Then it switches from negative to positive again between 1 and 2, and then it switches from negative to positive again between 2 and 3. Do you see that? Okay, so you can see that from the chart as well. You're looking at the y coordinates being negative, positive. Make sense, kind of? Or you can just look at the chart afterward, okay? So there's that, okay? So the knowledge of what we know in x to the third power function, what we know he looks like, will help us to graph those when we have weird points going on, right? Like we know x to the third power is going to look something of that shape, okay? That can help us, okay? All right, we have relative maxes and relative mins. Have we talked about this before? Well, hey. Oh, that you were not supposed to come in?
Yeah.
Hi, how are you?
I'm
What
good.
what you visiting for? I have a pin stuck in my shirt, so don't let me stick you. What you visiting for?
Done with class.
Oh, nice.
Christmas break is coming up and I'm gonna go home now.
Oh, nice. This kid hated my class, and he was in 2 of them. He was in Calc and Stats last year, and now he's like visited me like 4 times already, like twice. But anyway, hated coming to my class, and now I can't get him to go away.
And now I'm really good at stocks too.
There you go, right?
Yeah.
Perfect.
So I needed their
Perfect.
classes.
Nice. Yeah, right, exactly. Do you have to take any math classes now? Or not?
No.
No?
All done.
I don't know. All right, if you're watching this video, skip through that. There's a Caden commenter just showed up in my room, so there's that. Anyway, all right, relative maxes and mins. Here we go. We have mins and we have maxes, and that's where they're located. It's not the absolute highest point on the graph and the absolute lowest point on the graph, but it's like where the hills and valleys are located. That's relative max and relative min, okay? So let's go down here. Let's graph each one of these. And I should have had you guys picking points while I was talking to Caden over here. We have this function. Is this the same function?
Same numbers.
No, not the same. Same numbers as what you had before. And I have to do 5. Yeah. Go the same number. Whatever number you had before, plug it in.
Mine's 3,
I'll do 5. What?
0, 3.
Okay. You cheater. This is not fair. Whatever number you had before, plug it in. I'll plug in 5. I think that's right. By the way, do you guys know how to go back into your calculator and not have to type everything in again? You can go back and replace the number. Did you know how to do that? Okay, if you don't know how to do that, let me know and I can help you. Okay, anybody got any numbers? Daniel, you have -2? What'd you got? -9. Okay. -1? -6. Sounds right. 1 is at? Tate? What'd you get for 1?
-2.
-2. Okay. 2? -9. Okay. 3?
Negative 12.
-12. 4? Carter?
Negative 5.
-5?
Yeah. I don't think that's right.
No, could be. I bet you it is. It might be. Okay, let's try it. -2 is at -9. -1's at -6. 0's at 3. Wow, we got some weird things going on here. 1's at -2. 2's at -9. Holy cow. 3's at -12. I'm just guesstimating where these are located. 4 is at -5, and 5 is at 18, like all the way up here. What in the heck? We have stuff everywhere. What's this look like? What's his parent?
Nothing.
X to the 3rd.
He's an x to the 3rd power again, right? Okay. And he's a positive x to the 3rd, so he's going to look like this again, right? Okay. But do you see he's extra tall humps, right? You see that?
You should graph it.
Down here is what he looks like. He's all the way down here. I'm going to all the way down here, and then he comes up. Wow. And he comes down again. Are you seeing this? Something of that nature. Make yours look a little better than mine, but that's kind of what he looks like. I didn't hit this dot over here because he should be down lower. He should be like all the way down here. Something of that nature. Okay, so he's got extra tall, like high and low points, right? Okay, they want us to guesstimate where the maximums and minimums occur. Okay, so if we had to guess, he's going to have a relative max at where? A relative max. What?
3.5, 4. No, 3.25.
Where's like a relative max is like a hill. Where's the hill located?
3.
Right there. What's that coordinate right there?
0,
0,
3.
3 ish.
2, 4.
A relative min
Negative.
is like a valley. That is at wherever that point is. What we got there? 3, -12, something like that. You can look on the table. Okay, now it might not be 3, -12 exactly. It's probably like closer to like over here a little bit. It might be like 2.5 comma something, right? But it's gonna be close to 3, -12. They're just having us guesstimate where he's close to. Okay, makes sense? Like that. Okay, and estimate the x coordinates of which the relative max and min occur. There it is. We gave the x and y coordinates, but they were just wanting like 0 and 3 are the maxes and mins, right? Make sense? Good? Happy with that? Go to the back side. Let's talk about some other things. We have relative maxes, minimums, that type of thing. Let's talk about turning points. Okay, so looking at this graph up here at the top, we have that he's increasing from left to right. He's going uphill, right? And then he hits a maximum point. And then he turns around and he goes downhill, right? Okay, this maximum is a turning point. He turns around. He goes from uphill to downhill. That's where he turns at, right? Okay, same thing with this guy. This guy is a minimum. And he's going to turn around and he's going to go from decreasing to now increasing again. So any of these maxes and mins, these are called turning points. So if they ask for turning points, they're just asking for maxes and mins. Okay. All right, so let's go down here. Let's do one of these functions. Annual admissions to movies in the United States can be modeled by this function. That's a mess. Holy cow. That's a mess. Oh, heavens. And they want us to go 0 through 9?
Make Eli do a different number because we all
Right.
know zero.
Right. We're going to cheat, and I'm going to go grab my computer, and we're going to Desmos this, and I'm going to tell you what the numbers are. Okay? Okay. Sure. Somebody's got to read me the function, though, and help me out here.
0 points.
Hold on. I got to get Desmos pulled up.
I already got it.
What? You already got what?
Are you Desmos?
I was charging my calculator at home and I forgot to bring it, so I've been using that the whole time.
What?
Doesn't matter.
Oh, you already got Desmos pulled up. Do you have the numbers?
No,
Oh, okay. 0.006 x to the 4th. Okay, read it to me more. Minus point?
0.089
8.
6 x to the 3rd
Okay.
plus 0.37
0.37 x to the second. Okay.
Minus 0.746
Okay.
x
X
plus 8.95.
8.95. Okay. All right, I gotta go over here. F of x equals. Okay, here we go. We gotta do f of what?
1 through 9.
What's 0?
8.95.
Right, we don't plug that one in. 8.95. Okay, 1, f of 1. 8.49. I'll zoom in on the table. Okay, f of 2. Okay, 2 is 8.32. F of 3 is 8.11. F of 4 is 7.69. 7.02. Okay. Okay, 6 is 6.22. 7 is 5.53. 8 is 5.36. And 9 is 6.25. There you go. Kind of weird. It's kind of going back up at the end. It's decreasing and it's going back up again. Ugh. They should have not started these numbers whatever. Anyway, 0 is at 8.95 up here. Then we go down to 8.5 almost. Then we go down to 8 1/3 almost. Then we go down to 8.1 almost. 7.69, 7.02, 6.22, 5.53, 5.36, and then back up to 6.2 something.
How are you graphing this so fast?
I don't know. Because I'm fast. Something like this. There we go. Something like that. Okay, good. Describe the turning points of the graph. Whoa. What are turning points again? Max and mins. Okay, do we have any maxes? Like high points? Not really, because we don't know, like this first point, he looks like a high point, but we don't know for sure if he was going up before he came to that point or if he was going down before he came to that point. So that's not necessarily a high point. So we don't have a high point. Do we have a low point? Yeah. He is a low point at 8, right? Okay, describe the maxes and mins of the graph. Okay, so what is the min? We said it's at 8, but what does 8 mean? This is number of years since 2005. So what would 8 be?
2000 something.
2013 is where we have a minimum. So it is at the lowest revenue in 2013. Evidently people weren't going to the movies in 2013. I don't know. What trend is the, and it's end behavior. So what's happening on the end of the graph? On the right side, what's happening? It's going uphill, right? Okay. So we really can't talk about anything before this because maybe it was going up, maybe it was going down, but it looks as though that this is trending upward as we go beyond. So it is trending, I'm just going to say trending up after, I'll just say after 2013, it's trending upward. Okay. What trends in revenue does the graph suggest? Revenue going up after 2013. Isn't it reasonable that this trend will continue indefinitely? Will it continue to go up and up and up and up and up forever and ever and ever and ever and ever? Why not? What?
2020.
Because 2020, right? Like
It
it's
could
not
go
gonna,
down again.
yeah, it could go down again, right? And there's like we're gonna run out of people, or we're gonna run out of like seats in the movie theater at some point, right? Or whatever we're doing, right? So yeah, we can't. It's not gonna continue up forever and ever and ever. It's gonna level off at some point or go down. So I'm just gonna say no, for obvious reasons. He's not gonna go up forever.
Common sense.
Common sense, right? Like population. Like if they ask you for population, if they say the population in the United States is trending upward, will we continue to trend upward forever and ever and ever? Will the population go up forever and ever and ever?
No.
Like assuming that we go into like year 4,000 something, right? Will we still be increasing population? Why not?
Because if it gets too crowded.
We're gonna run out of room on the earth, right? Whew. That's why I'm glad I'm gonna be dead by then, probably, right? So anyway, will not continue. Population won't continue on forever. Okay, good. You guys have this paper in front of you. Let's go through.
Let's go evens.
Every third starting at 1.
Evens.
So then
But
you
I like
have
number
1.
5. Okay, we'll go evens on this page. 2, 4, 6. 2, 4, 6 on this page. I like that. Sure. Now number 4, they do not give you numbers
That's
to
not our
plug in.
paper. That's not our paper. Oh yeah, it is.
2, 4, 6, they don't give you numbers to plug in.
No. On 4 they don't.
Okay, 4, yeah, 4, they don't give you numbers. Let's pick some numbers. Should we pick some numbers?
No. Some even and some odd. -1 or -2, -1, 0, 1, 2, 3.
You think? Okay, sure. -2, -1, 0, 1, 2, 3. We'll see. We'll see if that gives us enough. Okay, what's x to the 4th power going to look like, by the way? He's going to look kind of like a W, right? Okay, so when you graph this thing, he should have kind of a W-ish shape. If he does not, you might need to plot some more points, okay? Let's talk about number 2. They already gave you the numbers that they wanted to plug in, but his x to the 3rd power. He's positive x to the 3rd power. So he's going to go uphill from left to right, like something like that. Or he might have like, I don't know, whatever, something like that, right? Okay, let's go to the backside. Backside, evens or odds? Which one do you want? Same number.
Even.
Evens. Or evens easier? Oh, no.
No, let's do
Sure.
odds. Let's do
Odds?
odds. What? No. Odds.
They look
Odds, raise your hand.
I don't even care.
Evens, raise your hand. Okay, it's odds. Odds, 1, 3, 5. There you go. Okay, they gave you the numbers. Should we talk about what the shape should look like? Or you want to figure that out by yourself? Shape. X to the 3rd power should look like one of these. If he doesn't, then you did something wrong. Or you're not done graphing. X to the 3rd, this is another one. Should look like this. When does he point downhill? We haven't done one of those yet. What? When he's negative. He's not a negative x to the 3rd. It's a positive 2. And then this guy is x to the 4th power, which looks like a W or something like that, right? Something of that nature. Okay? So there he is. And make sure you go through and find the zeros and you find the maximums and minimums. That's what they want for part A and B after you fill the table in. Okay? Good? Happy with that? Any questions?
No.
Okay. Goodbye, people in the video.